Bueno, buenos días. Gracias a todos los que estáis presentes, que habéis aguantado hasta el final. La presentación que nosotros íbamos a hacer en un principio era una mezcla de las experiencias que hemos llevado a cabo en Murcia, con Pedro Simón, con Iproma, con Faxa, los distintos proyectos en los cuales hemos colaborado, pero teniendo en cuenta que ya se han hablado en parte de ellos, pues hemos preferido aprovechar la oportunidad y mi compañero Jürgen que explique toda la experiencia que tienen en Suecia en distintas plantas sobre contaminantes emergentes. Así que le cedo la palabra a Jürgen, ¿vale? Y que os va a hacer la presentación. La presentación se va a llevar a cabo en inglés, aunque lo que son las diapositivas será en castellano. Si tienes alguna pregunta, consulta o duda, no dudes en preguntarlo, por favor.
Hello. Good. Sorry, my Spanish is not that good. I can say buenos días, gracias. Good. It's always nice to have the last presentation when you all are tired and just want to leave. But I will try to have this as fast as possible. It's a very, very important subject. And this is the only slide in the presentation that is in English. You have probably already seen a lot of the slides or figures, but I want to make it in a more practical way. You know that 90% of the medications that are prescribed today, they end up in the wastewater. Because all the medications that you are consuming are designed in a way that they will actually pass through your body. They do not want them to stay there. So that's why they end up in the toilet when going there in the morning or in the evening. So 90% just goes out with our wastewater from the homes. In Sweden, there has been a lot of interest from the press. And even though we do not have any laws for this in Sweden yet, the general public is pushing this forward. And it's also very important for the municipalities to show that we are working with this kind of topics, because that is a way to attract families to move to the municipality, that we can actually treat the water that we have. You do not understand what the newspapers are writing, but it says that ozone should remove pharmaceuticals. Ozone, you have heard before from our colleagues in the business from Xylem what ozone is. Ozone is a natural gas. We have it always protecting us very high up in the sky. But ozone that we produce can do really, really good things. It is natural. It has a very, very fast reaction. It reacts much, much faster than most of the chemicals do. And when the ozone has done its job, it turns back to oxygen again. So we call it the nature's own disinfectant. Gracias. I was not allowed to talk so much about our company, and I will not. But Primozone, the company that I come from, we only do ozone. That is the only thing we do. And our vision is to be the most competent ozone provider of sustainable treatment solutions. We are focusing on that, and we are really good in what we are doing. When it comes to our technology, there are many ways to produce ozone. We have chosen a little bit different approach in producing the ozone. The gas is the same, no matter what kind of ozone generator it comes out from. But how efficient I can produce the ozone and at what concentration I can produce the ozone and with what pressure I can produce the ozone is very different from all the suppliers on the market. I was just going to show one example, and this is something that we are trying to promote. It's with redundancy, because in normal cases for wastewater treatment plants, you do not demand redundancy. It's something that you use for drinking water because you always want to disinfect your water. But we think it's equally important actually to have this redundancy in wastewater treatment plants. So our modular system that we have actually allows you to have a redundant system already built in from the beginning. So that was my commercial part. Now I will come to, thank you, Jose. To something more important. I want to present in a very pragmatic way 2 big pilot studies that we have been doing. We have not been doing this ourselves. We have always been doing them in collaborations with others. One study that we just ended that has been going on for 3 years now at the Research Institute EWAG in Switzerland. I was not allowed to present anything from there. The result of that anyway will be presented later on this year at the International Ozone Association conference. But that study has specifically studied ozone in combination with activated carbon. But I will focus on 2 studies that we have been doing. One that we finalized in December 2007 after 3.5 years of studying. It was a collaboration between several wastewater treatment plants, some universities, and Primozone as ozone supplier. We did this at 11 different treatment plants in South Sweden. And for those of you who are very good in mathematics, you will only see 10 dots, but one of the dots didn't fit on the map. It's a little bit higher. But in total, 11 wastewater treatment plants. And why did we choose 11? We choose 11 wastewater treatment plants because there are 11 different kind of wastewater treatment plant process configurations in Sweden. So depending on how the configuration of the process looks, we want to see if we can use the same kind of control of the ozone. I will come more to that. The other project that we are doing right now, it's called Bonus Cleanwater. It's a EU-financed project, and in this, it's also a lot about ozone, but this project also contains to determine where are the main sources for the micropollutants that we have today. But not only micropollutants, a big problem in our society is also the microplastics. And we want to find in this project where are the sources coming from. In Sweden, for years, everyone has been saying it is coming from this football fields that are artificial. It comes from tires on the roads. But are we sure that those are the only sources? And that is what we will find out. One thing that we found out in this first study, and this is maybe a typical Swedish way to present the results, but we found out that you can remove a lot of the pharmaceutical by just using ozone. But even if you do not use ozone, the process in the water treatment plant actually removes quite many compounds very good without adding anything. In this particular place, this is a wastewater treatment plant with 45,000 people connected to it, or 45,000 PE. We did this as one of the last part of the projects, and I wanted to lift this up because this is from my home municipality where I live, so I'm a little bit extra interested in the figures that we received here. But if we look on the removal rates, we can see with already a little bit of ozone, we can remove quite much, but absolutely not everything. You need to increase the ozone doses all the time to really remove the major part of everything. But what we can see is, there are also compounds like ibuprofen, caffeine, that are almost gone, even though they come into the wastewater treatment plant. They are gone by the end of the wastewater treatment plant without any special treatment, which we thought was very interesting, and we were a little bit surprised about these findings. And it was the same on all 11 wastewater treatment plants. Thank you. What did we know in this project? I mean, even if we know a lot of data, we think that it's a good investment always to make a small pilot. Do not just go after data that you find in the books, because it is a big investment for you when you want to remove this pharmaceuticals or emerging contaminants. And to do a small pilot, to really determine it based on your water, is a really good investment. And I want really to recommend that, because on the curve in the bottom you will see that we use the same process everywhere in 11 different places, and you can see how much it differs with the same ozone doses. So take your time to do a pilot. I think it's really, really worth it. In Sweden, since we have no law yet, we always recommend customers that want to make this investment to make the investment that it can be built out, because you will never know what the law says in the future. You need to have a system that is flexible, not only with the number of people that are moving to your municipality, but also is flexible enough to cover maybe different kind of thresholds. Yes. Then I would like to present, and this is where I will bring most of the time, the bonus clean water project that we are doing today. And we are very happy to be with some very nice institutes and universities as Primozone. We are by far the smallest company in this group of companies listed there. But this is a project which we have learned, or all of us has learned, and made very nice findings. I just want to show some pictures. This is the setup that we are using in one wastewater treatment plant. It is one MBBR container with moving biobed reactor, coming actually from Anox, who was presenting earlier today. And we have to the right, with a tank on the top, that's the ozone container. If we take a look in the ozone container, it contains everything. We are treating a flow of 4 cubic meters per hour, and we are testing in this container different kind of ozone injection systems to see if we can find different results depending on how we inject the ozone in the water. And without taking too much away from what will be written in future papers, but there is a huge difference in results depending on how you inject the ozone in the water. The dose response curves for 3 pharmaceuticals we have done over time, and here you can also see that even with the same doses, it differs depending on what time of year or when you are doing this sample. And you need when designing your system, also need to take this under consideration, that it will differ depending on what time of the year it is. And this has not only to do with the biological load in the water, it is a lot of other parameters that are controlling this. Yes. The variations is really depending on the year. And what we learned is that the ozone dosing for remove the pharmaceutical is almost the same as we have seen in the other project. That doesn't differ so much. And another learning, and something that people are very scared of in general, is this: what will happen with the things that the ozone is treating? What kind of byproducts will I get? And you will get byproducts by using ozone. So far, we have not found any byproducts that are more toxic than what we put into the treatment plant. But what we have learned so far by using MBBR or any kind of biological filter afterwards, we can remove almost all the byproducts as well. So from our perspective, we will probably take the same approach as they do in Switzerland, that when you use ozone, you need to have some kind of biological filter after to take care of the byproducts. The cost for a regular treatment plant, if you calculate that in euros per cubic meter, is approximately 17 cents. Maybe this is not the same in Spain, but at least these are very similar in northern Europe or in Scandinavia. But for this 17 cents, half of the pharmaceuticals are still in the water. And that half that is still in the water is where the most persistent and bioactive residues exists. So it is very important that we actually try to treat this other half. During a period of 10 years, there was a project running in Sweden called Mistra Pharma. And that is the biggest project in the world to look into emerging contaminants and pharmaceutical residues that has been done so far. And I just wanted to show a comparison which they did. This doesn't come from the ozone supplier. It just shows the cost of treating with different kind of technologies. You can see that it differs quite much. And it turns out, and maybe that is why I'm showing this, is that ozone is the most cost-efficient solution so far. Another thing that we have found out that many people do not think about, people design a system because they want to remove pharmaceutical residues. But by using ozone, you also disinfect the water in a very efficient way. And we did a microbiological study on all the treatment plants of these 11 treatment plants, and these are the average what we found. So even though you had very high levels of coliform bacteria, E. coli in the beginning, by using ozone, you reduce them quite a lot. And if we would transform that into percentage, it will be, we do not do total disinfectant of the water, but we do a good removal of the bacteria. In Sweden, we have a very, very long coastline, and during the limited time that we have in the summer, where it's more than 20 degrees, most of the Swedish people try to go to the beach. And all the wastewater treatment plants in Sweden are discharging the water close to the beaches. So everyone is really interested to get rid of this coliform and E. coli bacteria as well. Yes. If I can give just some advice, because I have 1 minute left. Always do a pilot. Really recommend that. But a very important thing is decide for your removal goals, because it's a huge difference to set up 80%, 90%, or 95%. Maybe you are satisfied with 95%. To reach 99% will cost you maybe 40, 50% more. So you need to decide what kind of goals you want to have. Then, when it comes to ozone, it's very important how you control this. And we can say, and hopefully our colleagues in the business also agrees with us, take a practical approach. There are very, very many different kind of instrumentations. You can measure it in a very good way, but it's important that it's practical when you measure it. And it has turned out that most of the people, when controlling it, they are still controlling it depending on the flow of the water flow, not on any other parameters. Another thing that we recommend is to make sure that you inject the ozone before the reaction tank or the basin, because that will save on civil works, but it will also give the ozone a better chance to work with the contaminants. And when using higher pressure of the ozone or higher concentration, means that you can inject or get a better mass transfer of the ozone, meaning that you will not waste ozone that comes up to the surface that hasn't reacted with any kind of compound. So, that was all from me. I hope you understood what I said. If not, you are more than welcome to get the Spanish translation in the stand 2C06. Thank you very much.